The LTO Show, the premier podcast for leaders in the LTO tape storage community. Each episode dives deep into the business and technology issues that matter most. The LTO Show keeps you informed and inspired. Be part of the future of storage today.
Welcome to the LTO Show, the premier podcast for leaders in the tape and storage industries. I'm your host, Pete Paisley, and each episode, I bring you conversations with industry leaders who are contributing in special ways to the tape storage community. Our goal is to deliver fresh insights into the business case for LTO tape storage, and today we're exploring how tape storage is becoming the unsung hero in the age of artificial intelligence. If you've been following the AI revolution, you know that large language models, LLMs like ChatGPT, Claude, and Gemini, are transforming everything from how we work to how we communicate. But what you might not know is that behind these incredible AI systems, there lies an enormous data challenge. We're taking petabytes, even exabytes of training data that needs to be stored, managed, and preserved. And that's where tape comes in. Today, I'm thrilled to welcome Tom Coughlin, CEO of Coughlin Associates, a leading storage and market research firm. Tom is one of the foremost experts on storage technology trends, and he's been tracking the intersection of AI and storage infrastructure closely. Tom, welcome to the LTO Show.
Thanks, Pete. Great to be here, and I've been looking forward to this conversation.
Yeah, me too, Tom. Hey, share a little bit about your background before we jump in.
Sure. I've been in the data storage industry for over 40 years. I've had engineering, senior management positions in this industry. My company, Coughlin Associates, consults, publishes books and market and technology reports, and puts on storage and memory-oriented events. I'm a regular contributor for Forbes.com and media and entertainment organization websites. I've done a lot of stuff with IEEE. I'm an IEEE fellow. This 2025, I was the past president of IEEE. I've also been a president of IEEE USA and a director of what's called IEEE Region 6, which is the Western United States, as well as the past chair of the Santa Clara Valley IEEE section. And I'm also active with the Storage Networking Industry Association and with the Society of Motion Picture and Television Engineers. For more information, you can check my website, tomcoughlin.com.
Tom, before we dive into the technical information, let me ask you this. When most people think about AI training, they think about massive GPU clusters and high-speed storage and networking. Tape storage seems almost counterintuitive. Why should we be talking about tape in the context of cutting-edge AI?
Well, that's a great question, Pete, and it's one I hear a lot. So the reality is that AI training is a multi-stage process and has different storage requirements at each of these stages. Sure, during the active training, you need the fastest storage possible. For instance, NVMe SSDs feeding data to GPUs at incredible speeds. But once that training run is complete, you're left with massive data sets that still have enormous value, but don't need to be accessed constantly. And that's where tape becomes not just relevant, but I believe essential.
Let's talk about the numbers for a moment. When we say massive data sets, what are we really talking about here?
Well, we're talking about a scale that's really hard to comprehend. Modern large language models are trained on data sets that could range from hundreds of terabytes to multiple petabytes. GPT-3, for example, was trained on about 45 terabytes of text data. GPT-4 and newer models, well, we're looking at it significantly more. Some estimates suggest 10 to 20 petabytes or more when you include all the data generated by pre-processing, intermediate checkpoints, and model versions. And most people want to store all of those in case they need to retrain.
Staggering numbers. And these companies aren't just training one model, right?
Exactly. They're training multiple versions, running experiments, fine-tuning for different use cases, and constantly iterating. Each training run generates not just the final model, but also checkpoints, logs, evaluation data sets, and validation data. And all of this needs to be preserved for regulatory compliance, reproducibility, and possibly for future use.
Yeah, so we're not just talking about storing the final model, we're talking about the entire lineage of data that went into creating it.
Yep. And here's the kicker. You can't just delete this data. There are several reasons why. First, as I mentioned before, there may be regulatory requirements, especially, for instance, in healthcare, finance, or other regulated industries that mandate that you keep records of how models were trained. Second, if you discover a problem with a model, even months or years later, you need to be able to go back and understand what went wrong. Third, that training data represents a massive investment, sometimes tens of millions of dollars in compute costs alone, and you don't want to throw that away.
Right. But storing all that high performance storage would be prohibitively expensive, wouldn't it?
That's right. And if you tried to keep everything on NVMe SSDs or even on traditional hard drives, the costs would be astronomical. And that's where the concept of tiered storage becomes critical. And tape sits in one of those tiers as a foundation of that strategy.
Let's break down those economics. What makes tape so attractive for archiving completed LLM training datasets?
So it comes down to three factors: the cost per terabyte, the energy consumption, and the longevity. So let's start with that cost. Current LTO 10 tape technology offers about 30 or 40 terabytes native capacity per cartridge, or up to 100 terabytes with compression. The cost per terabyte for tape is roughly $6 to $10, and we can compare that to, for instance, $15 to $30 for enterprise hard drives, and significantly more, maybe 4 or 6 times more for solid-state drives.
Yeah, so we're talking about a 3x to 5x cost advantage right off the bat.
Yes, but the real saving comes from that total cost of ownership. Tape consumes zero power or very little power when it's sitting on a shelf. Hard drives in a data center are spinning 24/7. They're consuming power and generating heat that requires cooling. When you're talking about petabytes of data, those energy costs could add up.
Yeah, they do. I've heard some estimates that tape can reduce energy costs by 90% or more compared to disk-based archives.
That's correct. And in today's environment where data centers are under pressure to reduce their carbon footprint and energy consumption, that can be a huge advantage. AI training is already incredibly energy intensive. The training runs themselves consume massive amounts of power. If you can offset some of that by using tape for archive, it makes a real difference.
Yeah, and what about the longevity aspect you mentioned?
I'm glad you asked about that. So tape has a shelf life of 30 years or more when stored properly. Compare that to hard drives, which typically have probably a 3 to 5 year operational lifespan. For long-term archives, which is exactly what we're talking about with completed training datasets, tape can be a very reliable solution.
Yeah, now I know some listeners might be thinking, but tape is slow. How do you deal with that?
Well, that's the beauty of this tiered storage model. You don't access this data frequently, so tape works fine for storing that. And once a training run is complete and validated, that data set might sit untouched for months or years, for example. And if you do need to retrieve it, say for an audit or to retrain a model, you can afford to wait a few hours for the data to be restored from tape, having saved that money and storing it. Now, the key is that you're not paying premium prices to keep rarely accessed data on fast storage, but you can always move it back to the faster storage when you need it.
Can you walk us through what a typical storage architecture looks like for an organization doing serious LLM training?
Sure. So think of it as, for instance, a 3-tiered pyramid. And at the top, skinnier part of the pyramid, you have your hot tier. That, for instance, if it's storage, is NVMe solid-state drives, and it can also include memories such as the DRAM and high bandwidth memories. So this is where active training happens. Data needs to be fed into the GPUs at incredible speeds, so you're using the fastest storage and memory available. This tier might hold the current training data set as well as some recent checkpoints. The middle tier is what we call warm storage or secondary storage. It's typically high capacity hard drives in a high performance file system or object storage. And that's the place where you keep recently completed training sets, data sets that might be needed for fine tuning, and data that's accessed occasionally, but not constantly. Now, that bottom tier is cold storage. That's where tape shines. This is for completed training data sets, older model versions, compliance archives we talked about before, and anything that needs to be preserved long-term but isn't accessed on a regular basis.
Yeah. And data moves between these tiers based on access patterns?
Yes, exactly. Modern data management software can automate this. When a training run completes, the data might stay in the warm tier for, say, 30 to 60 days. And if it's not accessed during that time, it could automatically migrate to tape. And then if someone needs it later, it could be restored, either fully or just specific files that are needed.
Yeah. Are there specific examples of organizations implementing this kind of architecture?
While most artificial intelligence companies don't publicize the details of their storage infrastructure, we know from industry data that tape shipments have been growing. In 2024, we saw record shipments of 176.5 exabytes of tape capacity. That's up 15.4% from the previous year. A significant portion of that growth is being driven by hyperscalers and AI companies dealing with these massive data sets.
Yeah, and it's quite a growth rate considering this is a technology that some people had written off as obsolete.
So that happens a lot, and it's a perfect example of how technology evolves. Tape isn't competing with SSDs for active workloads. It's found in the niche as the most cost-effective, energy-efficient solution for long-term data preservation. And with AI generating more data than ever before, that niche has become very, very important.
Tom, it's not all smooth sailing though, right? What are some of the challenges organizations face when implementing these tape-based archives for AI data?
So there are definitely challenges. First, there's the cultural barrier. Many younger IT professionals have never worked with tape and view it as outdated technology. There's an education gap here that needs to be bridged. Second, you need the right infrastructure. Tape libraries, drives, and management software require upfront investments. For smaller organizations just getting into artificial intelligence, for example, that can be a barrier to entry. Third, there's the restore time issue we touched on earlier. While it's acceptable for archive use cases, you need to plan ahead. If you suddenly need a data set that's on tape, you can't access it instantly like you could with a disk or SSDs. You have to schedule it to be moved to a faster media.
So what are vendors in the industry doing to address these types of challenges?
We're seeing innovation on multiple fronts here. LTO 10 is out now, and there are generations up to LTO 14 on the roadmap, which will offer even higher capacities. And that means fewer cartridges to manage and even better economics on the storage. We're also seeing better integration between tape systems and cloud-native workflows. For example, S3 object storage on tape. Modern tape libraries can present themselves, again, as object storage, making them easier to integrate with AI training pipelines that are often built on cloud-native architectures. And there's growing interest in hybrid approaches, using cloud storage for some archival reads and local tape for others, depending on access patterns and cost considerations.
Yeah, and what about the role of cloud providers? Aren't they incorporating tape into their offerings?
Some are. AWS, for example, has been using tape in their Glacier Deep Archive service for years, although they don't ever advertise that very heavily. As AI workloads increasingly move to the cloud, we're likely to see some cloud providers offering tape-backed archival tiers specifically designed for AI data sets. And also there's work going on for people to do hybrid architectures where they have S3 storage in their local tape, but they also can work with the cloud, could be archived in the cloud or with other data sets. A lot of people want to keep, for various reasons, local control of their data, for example.
Yeah, those hybrid architectures give them the benefit of local control and local copies of the data, but the cloud providers still win in terms of geographically dispersed multiple copies of that data for companies.
And disaster recovery.
Yeah.
Yeah, and things like disaster recovery also,
So looking ahead, Tom, what's your prediction for the next 3 to 5 years? Will tape continue to be relevant as AI evolves?
So I think we need a low-cost archival storage like magnetic tape. And here's why. AI models are getting larger, not smaller, Training data sets are expanding, and regulatory scrutiny around AI is increasing, which means that more data retention requirements. And all of these trends favor technology like tape. We're also seeing some new use cases emerge. For example, some organizations using tape to create data vaults, immutable archives of training data that can't be altered or deleted, which is important for the compliance we mentioned before and for audit purposes. Tape's write-once nature makes it ideal for this. I think we're seeing tape becoming more invisible. It's being integrated into automated tiered storage systems where users don't even think about whether data is on disk or on tape. It just works, and it's cost effective.
Tom Coughlin, this has been fascinating. Before we wrap up, what's the one thing you want listeners to take away from this conversation?
So I'd say this: don't dismiss a technology like tape as obsolete. In the age of AI, where data volumes are exploding and costs are a major concern, tape is more relevant than ever. If you're involved in AI development or data management, you should be thinking about how tape fits into your storage strategy. It's not about replacing fast storage. It's about building a smart tiered approach that balances performance, cost, and sustainability.
Yeah, and for organizations that are just starting to think about this, where should they begin?
Start by auditing your data. Understand what you currently have, how often it's accessed, and what your retention requirements are. Then work with storage vendors or consultants who understand both AI workflows and tape technology. The key is designing a system that automates data movement between tiers so that users get the performance they need without paying for storage they don't need.
Right. Excellent advice, Tom. Tom Coughlin, CEO of Coughlin Associates, thank you so much for joining us on the LTO show today.
It's my pleasure, Pete. Thank you very much for having me here.
Great conversation with Tom Coughlin. Let's recap some of the high points from today's episode. First, AI training data sets are generating massive volumes of data that need to be retained, perhaps indefinitely. And we're talking about petabytes per training run, with GPT-4 and newer models requiring 10 or 20 petabytes or more when you include pre-processing, checkpoints, and model versions. The data requirement is only expected to grow exponentially as AI models become larger and more sophisticated. Second, tape storage is proving to be an essential archive tool for today's rapidly growing need for data preservation. Whether you call it cold data, archive data, or data vaults, storing this information can be far more cost-effective and secure on tape versus other options. We're talking about $6 to $10 per terabyte for tape versus $15 to $30 for hard drives, plus near zero energy consumption when data is sitting on the shelf. Third, the numbers don't lie. 2024 saw record tape shipments, up 15.4% from the previous year. A significant portion of that growth is being driven by hyperscalers and AI companies dealing with these massive data sets. Tape isn't obsolete, it's more relevant than ever. And finally, Tom reminded us that tape offers unique advantages for AI compliance and audit requirements. Its write-once nature makes it ideal for creating immutable data vaults, archives that can't be altered or deleted, which are increasingly important as regulatory scrutiny around AI intensifies. As you think about your AI storage strategy, remember Tom's advice. Audit your data, understand your access patterns and retention requirements, and work with experts who understand both AI workflows and tape technology. Don't dismiss tape as legacy. Embrace it as the smart, cost-effective foundation of your long-term data preservation strategy. I want to thank Tom Coughlin from Coughlin Associates for sharing his expertise with us today. For more information on storage technology trends, visit tomcoughlin.com. And thanks for joining us on the LTO show. Subscribe wherever you get your podcasts and join us next time as we continue exploring the business case for LTO tape storage.
You've been watching the LTO show. Thanks for joining us. The LTO show is produced and written by Pete Paisley. Thanks to our sponsors, these guys, these other guys. Don't miss our next episode coming soon. We feature industry leaders in data archiving that supports LTO storage.